So most of the pretty astronomy pictures we see from the Hubble Space Telescope and other places are taken in optical light or visible light, the kind of light we see with our eyes. And that's the kind of light that I mostly worked with when I was doing astronomy research. But Rachel worked with other kinds of light, infrared, and some stuff can only be seen at other wavelengths of light, other kinds of light that we can't see with our own eyes.
And one way that we can see black holes, which usually, of course, are black, is to observe them in the X-ray, which is pretty cool. So today we have an expert on that topic to talk to us, Dr. Steph LaMassa, who is a support scientist at the Space Telescope Science Institute in Baltimore in the US. Welcome, Steph.
Hi, thanks for having me. This is a lot of fun.
So first off, you study X-rays. You look at X-rays from stuff in space. So how do we see X-rays?
Right. So in order to actually observe X-ray light, you need to get above the Earth's atmosphere because luckily the Earth's atmosphere does a really good job of protecting us from X-ray light or X-ray radiation. And so there are several space-based observatories that have special mirrors that are able to reflect X-ray light onto a telescope and a detector that we can then use to observe really energetic objects in outer space that give off X-ray light. And two of the main telescopes in outer space that we use are the Chandra X-ray Observatory and the XMM Newton X-ray Observatory.
So why is it that black holes give off X-rays?
Yeah, so black holes themselves give off no light because that's one of the definitions of a black hole. It's an object so dense that light itself cannot escape it. So it's almost like a Zen riddle. How can we observe that which gives off no light? But as I mentioned earlier, stuff that falls into a black hole causes lots of energy to be released in that process. So we call that process accretion, where material spirals into a black hole. And during that process, that material gets really, really, really hot. So for the supermassive black holes, and these are black holes that are millions to billions of times the mass of our own sun, that material that spirals onto the black hole gives off energetic light and optical wavelengths, the type of light that many people are familiar with because that's the light that we're able to see with our eyes. And that light interacts with the gas around it and it gets scattered into X-ray energies. And so these feeding black holes are really good at producing X-ray light or X-ray radiation that we can observe with telescopes.
So the black hole in the center of our galaxy is currently dormant, not doing anything, so you wouldn't see it in the X-ray. Would there have been a time maybe in the past when it was feeding, when it would have shown up in your X-rays?
It's a really interesting thought, especially a couple of years ago, as different groups were measuring the motion of stars around this supermassive black hole in our galaxy. They found this one object. There's some debate as to whether or not it was a star or whether or not it was a dust cloud, but it was an object that had a trajectory where it should have dumped some material onto the black hole in the center of our galaxy, which would have caused our center of our galaxy to be a tiny, what we call AGN, active galactic nucleus. And it was super exciting. Like, this is going to be so cool. We can observe this in real time. It's going to be right there. And then we didn't actually observe the fireworks that we expected to. But there's still a bunch of groups who are studying that region and still finding some cool things that are happening. I mean, one thing that was really cool in this whole story was a couple of months before they expected the first encounter where things should have gone really bright, they saw this really bright emission coming from near the center of the galaxy. And they're like, oh my God, Sagittarius A star is going off early. This is so cool. And then they realized, like, oh no, wait, this is just a star that just happens to be close by, a so-called magnetar, which is a very strongly magnetic star. It just happened to have an outburst, and it just happened to be located very close to the supermassive black hole, at least in projection. And so it got some people really excited. And so the black hole astronomers were a little bit disappointed, while the stellar astronomers thought it was the coolest thing ever because they don't get to see those all that often. They're like, this is cool. Stop saying this is disappointing. And it was kind of fun.
Yeah, I remember when those predictions were starting to come out, and we were looking for it. All in my group, looking with our supernova search telescopes to see would we see
Yeah.
some light in the visible when this cloud got too close to the black hole. And I remember looking every once in a while using some telescopes, and nothing happened, nothing happened, nothing happened, and a whole lot of nothing happened.
I know. I know.
Astronomy is sometimes disappointing.
Yes, exactly.
Not every hypothesis or prediction is correct. I think we can all agree on that.
Right. It's how science works.
So, what does the future hold for studies of black holes and active galactic nuclei?
Yeah, so the future is bright, even though these objects are dark. There's, sorry, I had to have a bad joke. There are lots of telescopes that are going to be coming online. Uh, James Webb is going to be launching at some point, and we don't know when, but it's safe to say in the next couple of years it will be launching. And what's exciting about that is because James Webb studies infrared light, it can find black holes that are enshrouded by large amounts of dust, and black holes that formed in a very early universe where the optical light is redshifted into the infrared. So there's a lot that we're going to learn about early universe black holes when James Webb launches.
So finding more black holes, seeing how they feed, how they grow.
And how they interact with their host galaxies. So another cool thing is that sometimes these black holes give off like lots of what we call outflows. So some of their power extends into the host galaxy, and we can map that out in the X-ray light. We can see it in the infrared light and the optical light. And in some cases, this energy output is really powerful that it seems to affect its host galaxy surroundings. And so there's some theories that say, well, maybe black holes could actually stop galaxies from growing because they're giving off all this energy. They're heating all this gas in the host galaxy, so that gas can't cool and form stars. So there could be a way that these black holes are inextricably linked to the galaxies in which they live. And so the more that we're going to be able to study these outflows, the more we could try to understand what the relationship is between black holes and their galaxies.
So the future is looking for more black holes, looking at how the black holes eat, grow, and spit up all over their surroundings. So not different than child rearing, I guess.
Absolutely. And actually, someone made a very similar comment at a conference I went to about this topic a couple of years ago, but he had just had a baby kid. And he's like, it's like that can't be like, an 8-month-old. They yell at you, they spit up, and you just kept on going. It's like, oh, you didn't get much sleep last night, did you? You could see where the rant is coming from.
All right. Well, thanks for joining us, Steph, to talk about your black hole children spread throughout the universe.
And today I learned black holes are like babies. Cheers.
Thanks for having me.